Okay, so the machine learning, exercise, right? So this folder, ShopSpear AI Lab, this is the folder that you see in the GitHub, the location that I have actually provided in the description. So if you open this folder, you see different, files here, like data, knowledge base, product images, and this is to, generate the data. This is the code if you want to generate more random observations and some notes. And this is the blueprint. Means if you open this file, it helps you to understand the relationship. In every organization, you see this sort of, sorry, one second. Yeah. So you see this sort of dictionary. Maybe this is a data dictionary, or the schema definitions, etc. Right. So here we have clearly ShopSpear. Already we discussed about this company. Right. This is again a fictional company, and this is the fictional data that I have prepared just to walk you all through data analytics, and machine learning algorithm. That is churn prediction classification. Right. So this is a synthetic e-commerce data set. Synthetic means it's a generated, like, using some codes, random numbers, codes, etc. So you can directly use this data. Now, what is the data scale here? Right? If you look at here, 1,000 customers, this is again not the real data. Okay. So this is the one which actually you can treat it as a dummy data in layman words, or a synthetic data. It's a proxy just for your practice. Okay. So for ML and CNN, RNN, LSTML, NLP, GenAI, RAG, and agentic AI, everything, all the algorithms, whatever I discussed in theory, the same I'll be walking you all through the hands-on. So 1,000 customers, and we're assuming 500 products, 10,000 orders, 30,000 clickstream events, 5,000 reviews, 3,000 support tickets, 250 product images, right? All data is fictional and safe. This is not copied from any organization's website. This is fictional, okay? For training and demo use, that's it, right? So this story, just to refresh, ShopSpear is a fictional retail or e-commerce platform that we were discussing throughout our masterclass journey. Right. Now, if you look at here, so what sort of tables you have, right? So let me spend few minutes and explain about the data, right? So you have tables, structured data, right? All these data set tables, this is clearly structured data. Structured data means it has some rows and columns. For simplicity, I have given all these as a CSV file. Okay, but in the real time, in the real organization, when you are working as a data scientist or a AI expert, you see the data, could be stored somewhere in any warehouse. Could be AWS S3 or any other Informatica Teradata, any server. Okay, or SQL server, whatever it is. But for now, just for our practice, we're assuming all the data is available in. So download this data, all these folders, and put it in one folder. Give the same folder path in Python code. When I mention as a comment saying that, update the path. So whatever machine, your personal machine's path, right? Just update that one. So automatically the code will access this data and run the analysis. Customers.csv. This is the file which has data about customer information, right? So customer ID, customer name, all those things, city, etc. Products.csv is having product catalog, right? Orders is all the orders where the transactions happen, right? So that data we have mentioned. Order items, what are the line item level, SKU level, clickstream data. So once they come to the website, right, which area they are actually hovering, which product they are browsing, all this clickstream data is available in clickstream.csv. Reviews is, suppose if a customer is giving any review, that is given in reviews.csv. Support ticket is, suppose if a customer raised a ticket, right, saying that, okay, I have an issue, a technical issue, I did not get my refund, or I was not able to, or I paid the money, but it's showing that the payment failed. So these sort of tickets stored in this file. Inventory, what is the stock actually exist in the data set. Daily sales, the sales time series sales at day level, sales. This data we can use for LSTM, right? And then the product label, image labels.csv, 250 images we have, right? So this is a brief about the data, the fictional data that I have created to walk you all through the exercise that we discussed, like churn prediction, LSTM, GenAI, everything, right? Now, so the mapping, hands-on mapping. So this is important. This is very, very important. Whenever you are dealing with multi-tables, right? So multiple tables, so more than one table, more than one schema. So you have to understand, right? So what is the relationship between one table to another table? So here also for the exercise, for the simplicity, I have given the the exercise that we are working on classification, CNN, RNN, LSTM, NLP, GenA, RAG, and agent decay. 8 exercises that we are actually doing. On top, of course, I will be walking you all through EDA as well. So first we will be doing EDA, exploratory data analysis, then the 8 use cases. Okay, classification, CNN, RNN, everything. Right now, clearly you can see what data is required for classification, what data set is required for RNN, everything it is available in this hands-on mapping. Then it comes to the data dictionary. So customers table, what are the key columns and what is actually this table about? Similarly, products, orders, everything. Okay, so this is the brief, the blueprint of all the tables. Now, if I come to this folder, see if you see here, knowledge base, product images and everything. So data folder. First, let's discuss about data folder for this exercise. The remaining I'll discuss whenever we need those data sets or folder information. So the data set, all these tables, whatever we just discussed, you have here. If you open clickstream data, so event ID. What is the meaning of event? The moment user entered shopsphere.com. So that is one event. He clicked one product ID. He clicked one image or he did something. So session. In the same session, he might have done multiple events. So clickstream is nothing but the moment user enter into the portal shopsphere.com and whatever activities that the customer is doing, everything is captured by event and by session ID, date, time, whether it is a web or a mobile app or Android app, Apple, right? So what type of product he is actually doing, event type, is it a page view or a purchase or a product view? It's simply only he's searching, right? So all these different things are available here, and the product, the respective product ID and search query. So what he's actually searching, if it is a search related event, right? Page load. The page load is basically, okay, page loads microseconds, right, or milliseconds. So how many ms seconds that time basically this is. Device type is mobile, desktop, etc. This is about clickstream data. Then the customers table. So customers table, you have clearly customer information, customer ID, customer age, gender, city. I mean, randomly I have given few cities in India, from India, okay, respective state. This is not US data. So this is India related data, right? So sign up date, when the customer actually signed up for, the shopspare.com, and if he is a loyalty customer or not, and he is using mobile application or a website, right? If it is a web based, it's 0. So it's called flag variable, guys. Okay. So flag means what? Uses mobile app, yes or no. If he is using mobile app, yes. If not, it is 0. Similarly, what is his preferred channel? Whether it is an application like Android or Apple iOS app or web page. And did he or she opted marketing? Marketing opt-in means you have to get the customers solicitation to send campaigns. So this is very, very important. If he says 0 means you should not send marketing campaigns. So no means he is not interested to receive marketing campaigns. So this information is important. Okay, that's about customer data. Then sales data. So whatever sale has happened, right? So this is the date. Sale is SKU. SKU is the product ID basically. It's actually, suppose if you have a candy bar, for example, or a shoe. So one shoe item, right? So it has given one SKU code. Okay. So then units sold, how many units it's sold? Is there any promotion is running on that unit, on that product? Like what is the price? So this information is sales. Then inventory. So inventory is basically stock. So if you want to do stock out, you can actually use this data to predict how which product may fall in under stock out. SKU, the product ID, warehouse ID, which warehouse this product exists, right? So think of Amazon example, right? Amazon may have hubs where the products are stored in the warehouse. They keep all the products. Whenever the customer is giving order, then they start picking up and deliver it to the customer. Current stock, how many, reorder point. The moment it reaches to 250, again, you have to reorder. What is the supplier name, supplier lead time days, how many days he will take, to send, I mean, suppose if you are making a purchase order, right? He takes 19 days. So average daily sale 30 day, last 30 days on average it is 2 units sold. Stock out risk, yes or no? Is there any risk already? Business has given a flag saying whether this particular product is having any stock out risk for next 14 days. No. All right. So that's about inventory information. Then order items. So order items is basically, so whenever you are making a purchase order, right? So what is the order ID, product ID, SKU, how much quantity, what is the price, discount, line value, right? If there is no discount, the same value you see here. If there is a discount, then it is, you have to put the value over there. So 3 quantity, right? So 3 into this minus 20% discount, it will be 2,425. So that is your order items. Customer have ordered this one on this discount. Then orders. So this is also related to order. So what is the channel, which city the customer is having, I mean, place the order, discount, promised delivery days, how many days that the ShopSpear actually has promised, actual delivery days. Is there any delay? Yes, there is a delay here. If you look at 2 days delay, this customer may not be happy. So this is this a return product? Is this a first order product? Right? If you look at the flags are very, very important. These are all features, okay, that tells the behavior of the customer that may impact your churn also. So is there any return flag? Is there any first order flag, etc.? So all these are basic, simple things only, right? Because you definitely, most of us, we do online shopping. So you're familiar with all these things. That's the reason I picked up this exercise. I mean, this business problem. All right. So this is about orders. Now then, product image labels. So you have different files. I'll show you in another folder. I have images also. Product one image, product two image. So like that, there are, I think 500, 250 product images exist in the data set. Then products. So what sort of products actually ShopSpear is putting for sale? So this is product ID. How many products we have? 500 products. The respective SKU code and whether it is an apparel, okay? And what is the brand? What is the product name? Price? What is the rating of for the product from the past customers who purchased it? When the product got launched on shopspear.com? Is it active or not? And the respective image. Okay. So please spend some time, understand if you think you need more time to digest this data, because understanding data is very, 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 very important for an AI expert. If you're not understanding the data, you can't build a meaningful model, right? So then the reviews, the customer one, review ID, order ID. So the customer has given this review, value for money, I'm happy with this product and would buy again. So what is the sentiment? Positive sentiment. So here this guy given review for the product. So on the product is this one. Where is the product? Yeah, this is product P0027. Is the product ID, order ID, customer ID, date. Right? Now you think each table has some information. So if you want to get a 360 view to build a dashboard for business intelligence and reporting, you have to join everything. That is called as granularity. First, each table you check which granularity it is there. I'll show you in Python code for our ML purpose what tables we are considering and how we actually join these tables. Okay. So if you are still, kind of confused on this one, just it's a basic concept, joins, table joins, could be SQL or could be Python. You can explore on that, right? So this is about the customer reviews. So the last one is support tickets. So what is the support tickets is whenever a customer raise a ticket saying that he or she is having some problem, either through refund or shipping or damaged product, right? So different issue types, and if there is any brief text from customer, that is also gets captured. So see, now if you spend time on each of the tables, right? Each table has a story. Each table has a data, some data. So if you run analysis, it gives some story. So that is basically data analytics. So you have to extract the insight and tell to the business saying that, hey, this is the actual reason why there is a decrease in sales, right? So that is the reason data analytics is very, very powerful. The way how analyze the data by combining different dimensions and derive insights. That is very, very important. So here we have ticket ID, customer ID, which date actually the customer ID has raised a ticket, what is the issue type, urgency, right? And then resolution time. These are all past tickets, right? So these past tickets. Suppose today, if you are, extracting the data of last 1 month or last 6 months, refund status, and these will help you to identify the churn, right? So whether the customer raised a ticket, but it is not resolved for more than 10 days or 20 days, then there is chance that he may churn, right? So that's about the structured data. Now, so let's go back here. Knowledge base. So here some policies. This is actually for our what we call GenAI purpose. So some text files have given refund policy, return policy, etc. That we will discuss when we run. These are all images, product images. It's a random, I've generated through some tool, right? So it's this one. So now let's start with the data analysis, exploratory data analysis by using all these tables and then run machine learning algorithm using, I'll explain different algorithms, how they work and all, but I'll also explain the business problem and how to come up with the hypothesis, assumptions and everything. Okay. So let's do clickstream table EDA. Okay, so here, if you notice, I've clearly mentioned uh, that pen is not allowing me to write here. Okay, sorry. Then let me. Okay, cool. So okay, start from here. Start 1, 2, 3. Start. Okay, now I will walk you through the exploratory data analysis. Okay, so this is very important for any data scientist or AI expert before they run the model. So this is, I'm giving only one dataset example. If you want, you can use the same code, change the column names and run the same for other tables as well, right? So this is a reusable code, right? If you look at, so first you load the data. Then what I want to do is I want to check the data quality, like accuracy, completeness, consistency, timeliness, validity, uniqueness, all these things, right? Then univariate analysis. So I want to analyze each and every column in this table, clickstream. Univariate is nothing but one variable. Variable is nothing but column. Okay, in the table, you pick one column and analyze and come up with some observations. Right? So that is univariate. Temporal means if any data, event or data which is based on time. If you want to see the trend, like since last 1 year, since last 2 years, by day, by month, by week, how the number of events, for example, is happening, that is called temporal analysis, time-based analysis. It is to show your key activity information over time. Behavior analysis. So basically the conversion funnel. So where actually the click stream, when they click something, where the purchase happened or not. Search query. So there is a search option, users search something, what sort of search they are actually doing it. So this is a basic EDA. If you want, in reality, you talk to your business and based on their ask, you can simply apply different analysis or analytical methods in Python on the same data set. Okay. So here first what you have to do is you have to give the path. So once you download the table, I mean the data set or data folder, update the path. This is my personal machine path. Okay. So it will give error if you run the code as it is. Change the path here. Okay. And these are the libraries from Python or in Python which we need to run the respective analysis. NumPy, numerical Python. To handle all of your numerical analysis, you have to import NumPy. Pandas is to read any table like CSV or any format. So pandas is required. So there are inbuilt methods within the library. So you simply access those methods and run your analysis. So this part is to pull whatever libraries is required. Right now, once you get this data, customers, sorry, clickstream.csv from this folder. So I want to save all the outputs, whatever I'm running in the analysis into this folder under the same main folder. Okay, EDA underscore update. Now, what is the funnel order? I have, if I open this data set, clickstream. So again, we discussed a few minutes back, right? So this is your data set. String data set. So what I want as an order is, so I need page view, search, product view, right? First, we see which page he is in, and then what actually he is searching, and then what is the product view. Then add to cart, remove from the cart, purchase, right? This is the funnel. Funnel is nothing but the flow, right? If you take any marketing funnel, right, from any company, it says that, okay, where is your master base, and how actually the base is getting filtered, and finally they are purchasing. That is actually called funnel. Funnel is a kind of path where it helps you to identify or understand where your customers are landing, what activities they're actually doing, and then whether they're purchased or not. Okay, so the page view, the search, here you have page view, uh, the event type, right? And then the search, what actually they are searching, this one, this page view, search, and from event type, what else we have? Product view, then add it to cart, remove cart, and purchase. This is the order that we are giving. So the analysis also we get in the similar order. So some basic, Python. So if anyone is completely new to Python, it's very simple programming language. Okay. So if you want, you can do any like geeks for geeks, right? W3 schools, simple tools. You learn Python very easily, or you just give a prompt, give the column names and give a prompt in any Copilot or any Codex, etc., or any Chat GPT kind of tool. It gives the code. Okay. So the important thing is the logic, what actually you are doing. These are all some sort of, when you are printing something, you're setting up some instructions or settings. So you're saying that, what is the file name whenever you open the file name. So while saving, what actually you have to do all those things. So this is optional and you can remove this, nothing will change. Okay. So now, always write Python, please learn in such a way that you define all of your functions, whatever function you have. So this is the load data function, right? First look function, then data quality report. Then there is a function for univariate analysis. Then there is a function for temporal analysis. Then there is a funnel analysis, right? Customer session analysis, search analysis, right? Everything, you write all the functions, then you run the main function here. So each function has a capability, right? So this one, first I'm loading my data. Already I have given here my path. This is the path, this is the file name, and I'm asking machine to store my output. Okay. So load data, just load, and if you want to put something, you can actually give as a comment. Wherever you see this hashtag and all, right, these are the comments. Then the first loop. So if you want to see few rows of your data, you can do the first 10 rows or 5 rows, etc. The quality, what are the things we have to do? So in the data frame, DFS data frame, isNA is a method. So if there is any missing value, so check the missing values and bring that to me and show what percentage of data is missing from each of the column. That's it. You're simply printing that part. So Python is just like simple English. Okay. So see, if you read here, you're computing how many observations are missing and the respective percentage. Then you are calculating that the completeness part and giving as a print option here. You're printing in the output. I'll show you in the output here. Then else, yeah. validity. So what is validity here? So suppose if there is a time, right? So bad time, event time, you're actually calculating. If there is a missing value, you are assigning it to bad time and you are counting it. So same way how we did for other columns. So you're checking the quality, consistency. Okay. Then if there is any distinct, what are the distinct values? Suppose if you want to see the distinct values, it will actually throw the distinct values. So a simple base analysis on this particular clickstreams data just to understand the quality. Then the univariate analysis is it picks each and every column. So right now here I'm using event type, device type, and channel. So do we have event type, device type, and channel? These three columns. These three columns versus I want to understand the distribution of each and every value count is it counts how many times this each of these occurred. Okay. So page load MS is how much time it took actually when customer is opening. So that analysis you are doing, and you are actually rounding that and getting the percentiles of that particular by each of these channels. I mean the categorical columns. Temporal. So you get your time, event time, right? So extract the date, hour, and weekday. Then how many events happen per day? How many events by hour? How many events by weekday versus weekend? So these sort of analysis just to understand the behavior, right? Then the behavior analysis, the funnel, as we have given the order earlier. First, it analyzes how many customers or orders, etc., by event type. Then we have the product view, add to cart, page view, etc., etc. Then it will count the distribution and show you as a funnel. Right, then the customer and session level analysis. So how do we get to know the customer and session level? So based on the customer ID, how much time actually he spent on each session, right? Session duration, so the mean calculations, etc. Then the search query. So what actually they are searching, that is search query analysis, simple function. Then you're running all the functions here. So let me run this code. See, to be honest, I'm not spending much time on Python. My goal is to explain the analysis and the business logic so that you can run the code and understand. That is main important because coding is simple. If you give a prompt, you get the Python code. But you need to understand the analysis and how you best generate the insights is important, right? So yeah, let's go through the output. Clickstreams CSV. So this is the data, right? This is the table. What it is saying, there are 30,000 rows exist in this table, right? And what are the different column types? Event ID, customer ID, right? Event ID, customer ID, session ID. So object and date type. Object is basically if it is not a number, it says it is object. In Python, there are different data formats. I'm sorry, data types. Object, integer is a number, float, and then date time. So event time is a date time format. So Python will understand whether it is a date or is a number, it's categorical, etc. Let categorical means any column with some categories like page view, purchase, etc. This is not a number. This is category. So this particular event belongs to a page view category. Channel is also a categorical variable. Device type is also a category. So something which represents a characteristic, right? So that's a categorical variable. So it displays the respective formats, and then it also helps you to see the data, just to get a glimpse how the data look alike. Very important, NaN means Python. If you look at here, it's a blank. So blank is written not a number, it's a blank. It's a missing value, right? Then similarly, page load, MS, device type, etc. So some brief first look. So this is your first function. We come back here. Where is the first look? Data quality. This one. This is the first look. It's just giving some brief about the data set, right? Then the second output, data quality report. So we check the missing percentages, right? It says that search query column is having 86% of data missing. You come here to see how many of them are missing. See, these many rows. The same actually it is giving here. 25,000 rows is having missing values. This is important. If these many columns rows are missing, so means 86% of, I'm sorry, your data is missing. So it's difficult to include this sort of data in any modeling purpose. That is why missing check is very, very important. So uniqueness. Is there any duplicate event ID? No, it says zero. no duplicate rows, right? Unparsable event time. So whatever the event time you have, is there any unparsable like the out of range, etc.? No. Non-numeric page load minutes. This one, no. Right? Negative page load minutes, no. Page load minutes should be greater than or equal to zero. No, greater than zero only. Right? Within 0 seconds, you don't open the page, right? So definitely greater than zero. Then yeah. So this is actually 30,000 ms. Something is miss here. See, if you look at the reason I'm showing Excel is just for you to show. So it's saying that greater than 30, there is a oh, there are no 30,000 ms. Yeah, that is the range. So possible sensor pH. There are no observations which are, maybe we discussed about outliers, right? So kind of outlier. Right now, then consistency, channel, three distinct Android, iOS, web. Suppose why this is important, the unique values or value count. Suppose if you see any category which is unusual, then you can immediately flag to your data engineering team, right? Event type, the distinct event types, add to cart, checkout, page view. This is important because you have to go through all these and understand if something is really making sense to the business or not. If not, you have to raise it. Device type is desktop, mobile, tablet, etc. Right? And the range of the date time is 25/11 to 25. So it's completely 1 year data. January 2025 to December 31st, 2025. 364 days of date. Right? So accuracy, because if you have any other ranges and all, you can compare and all, but accuracy here cannot be measured from the file alone, requires comparison to a trusted source. If you give a base file, it will compare the ranges and tell, okay, in the base file, what you mentioned, the range versus this range is not in sync. So that's how accuracy can be measured. Now then the univariate analysis. So each and every event, like column, right, product view, etc. How many observations are there? Purchase 1552, remove from cart 895. So event type distribution means what? In the event type, if you look at this event type, there are, you look at it, there are few unique values. It is giving simply how many times this product view occurred in this data set. Simple. How many times page view occurred? How many times search occurred? Right? That is the distribution of a categorical column. Then similarly, device type, this one. How many transactions in this table, how many events happened through desktop, tablet, mobile. Channel also, web, Android, and iOS. So what you can conclude here, most of the transactions are happening or click streams are happening through web only, not mobile application. Page load percentile, like what is percentile means? Simple. Percentage, percentile, quartiles, right? Deciles. It actually divides the entire data into equal parts. Percentile is one percentile is a percentile. If you sort your data, it divides the entire data into 100 equal parts. So it says that 50th percentile is this one, 90th percentile is this one, 95 is 3000 seconds ms, and 99 percentile is 3523 ms. Why this is important? This helps you to understand the distribution of the data, right? If you see 0.95, this 95th percentile is 3000 and 99 percentile is 35,000. That means there are some outliers. So that is the reason this distribution is important. Temporal data. So I think we build some charts, right? So that chart is stored in this EDA output. So I'll show you that in a while. Temporal. This is distribution channel. It's a plot again, channel distribution. You can easily see which channel is more. Like if you look at here, right? So clearly you can say my web is more. Similarly, if you come to device type, almost same. There is no much difference. And event type, product views. People are spending more time on product view and page view, but that's obvious, right? It's a funnel. They come, they search, they see. Finally, only few of them they purchase it. So that is what actually clearly it is showing. Then the distribution of page load. So this is what actually your percentiles that we have seen. It's a histogram basically, right? This is good. The distribution is good, not really much outliers. So you can see that as a good distribution. So events by hour. Means suppose if you want to compare in a day, typical day of all of your transactions, right? So 1, 2, 3, 4 is 24 hours. Out of 24 hours, in which hour more events are occurring? I think it's almost same. So R is not really making an impact because this is across the global, across the country, right? So that's fine. Then events by weekday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. This is a fictional data, right? So that's the reason you are not seeing any difference. But in real data, you definitely see Saturday, Sunday, you see more number of events occurs per day also. This is a per day distribution. And this is the funnel. If you look at here, so purchase, how many people, how many events are actually page views, search, product view, cart, from cart, remove from cart, people are removing. So it's a purchase. So this is the distribution of your event counts, right? So that is about your univariate analysis and different things. This is session analysis, basically how many customers, unique customers. Unique customers means this event, this customer ID, for example, I'll show you just to understand. This is very, very important. If I pick one customer ID, right, this customer ID C0001, this guy, you know, made 35 events, right? Suppose if I filter for one particular day, there's only one event, I'll show you another date. Sorry, I have to select date 2025. The same customer ID, during February month, multiple sessions. What he did page view, page view, page view. Finally, he purchased. So how many unique customers? 1,000 customers. What is the event size, average size? 30 events, and max is 47. Similarly, unique sessions, time, etc. Right? So search query. So what is actually the search query? Non-empty search queries are 4,000, right? So 4,000, the remaining are blank. People who searched, what they searched: wireless headphones, face serum, cotton shirt, yoga mat, running shoes, etc., etc. Right? So this is EDA, exploratory data analysis. You are actually deep diving into the data to understand. Now you know, right? What are the different parameters of funnel and average distributions, sessions times, different sessions, which session is spending more time, etc., etc. So you got a clear understanding of your clickstream data. Similarly, the same code, you can simply change the column names and table names and try for other, sorry, this one, other tables like customers or daily sales and inventory. You can practice this. See, try to analyze more and more data, all these tables, and get more story. Like, I mean, get more and more observations about your business. Then you will be a good data guy. So you have hands-on on your data. Okay, you can tell like, okay, what is the average sale of so and so category? What is the average sale of customers with so and so products, etc. Right? So now I hope you got a clear understanding of EDA. I've explained the process and the output. I have not spent time on Python code because please, you have to try yourself or simply use any GPT based tools. So code is nothing. Simple prompt will help you to give the code, but try to understand what actually you have to do. Right? So you have to explore the distributions. You have to see different categorical versus numerical cross tabulation, univariate analysis, right? And the distribution of the data. All these things will help you to create a story, the base story. This is the EDA example. Right now, we'll do the machine learning part. Now we got a base story. I'll explain now. Okay, so before we go through the data and Python code for our customer churn prediction, so let me spend some time and explain what is machine learning. Theoretically, we discussed in our master class in the previous session, but mathematical intuition, right? So simple. Now our business question is what? So customer churn. So customer churn. So can we predict which customer is likely? This is very important. It's a probabilistic situation. You're not saying that, compulsory this customer will churn. No, this is likely to all predictive models, all AI models, whenever you're predicting. Prediction is basically likelihood. Okay, so you are giving a probability that a customer may churn. So likely to stop shopping at Shopspeare. Okay, this is simple. This is the business problem statement. Can we predict it? I need to understand which customer. So to prepare the data, the target is the variable or the feature which you are actually predicting. Okay, so this is basically customer one, customer two, three, four, and so on. So this guy churn, yes, no, yes, no. What is this data? This is past data, past 6 months or past 8 months or whatever data you have. You take that data and define your target, right? Based on the rules. The business may say that, hey, last 6 months, suppose if he has not made any one purchase, right? Then he is kind of inactive or churn, or simply he log out, or he wanted to deactivate his account on Shopspeare, then also it's churn. So check with the business, get the rules, apply those rules, and define this tag churn yes or no at a customer level. Okay, that is the first thing you have to do. Prepare your data, okay, with the target variable. So my target is whether the customer is churn or not. So now I'll explain what is this is a classification problem. We are not discussing regression problem. I'll try to bring regression in another playlist. Okay. So classification problem. So what is machine learning? Imagine you are a customer service manager at Shopspeare, right? Every month, let's say 100K customers shop. Okay, some will purchase, some come back, some never return. Then maybe your leadership team asks, hey, can we identify customers likely to leave? Right? So traditionally, we may create rules saying that, okay, if a delivery delay is so and so greater than 5 days, right, and rating is greater less than 3, then there is a chance that this customer may churn. But how many rules that you design like this for millions of customers in reality, right? It's a manual thing. Then, like 1 million customers, 100 variables, and thousands of combinations, right? So we cannot write all those possible rules. Then here comes our machine learning. Machine learning learns those rules automatically from the data. Okay. So for example, if I say that, let's say delivery day, right? So delivery, I'm just giving one example, right? This is a rating. Then, I'm sorry, support tickets. Then churn. So take the past data. This customer had a zero delivery day, but rating is, let's say, a 5 rating. Customer ticket 0. Then this guy will churn? No, right? This is a basic rule. But this customer, second customer, 7 days delay in delivery, and rating he has given as 1 out of 5, and he raised 3 support tickets, for example. Then there is chance of giving. So these input columns, right? So these are called as features for any business problem, right? So again, you have to think about the causation also here. Since delivery delay is a cause and the effect is the churn, yes, right? That is business acumen. So you should have basic business understanding while defining the churn or the target variable, right? Then similarly, is rating affects the churn? Yes, of course. If the customer is giving very low rating, 1, 2, then there is a chance of this guy may leave, right? So these are called features, and the target where actually we want to get the answer is actually the target variable. I mean, the column is target. So machine learning job is build the relationship between your features. This is X, I'm sorry, this is X. Your features and your target. Simple. Now, always, why I prefer to give a simple layman equation, because most of us, we gone through this in our school days, right? So anyone can easily understand. So you have a X set of features, you have your target Y. Of course, don't think that, how come my Y is in our 10th class or 11th class, we studied Y equal to A plus BX is a linear space on continuous variables. There is a special form of this which is your classification problem. If you apply logarithm and then do probability and all, there's a math, you don't need to worry about it. But think of this one, if there is a classification problem, your y will be it's a probability or log odds, etc. I'll explain those things, right? So this machine learning try to learn relationship between features, your X and your target, right? So let's discuss about the first one. So I'll be walking you all through 4 algorithms, okay? So one is logistic regression, and the second one is decision tree. The third is random forest, and then XGBoost. If you are familiar with these 4, and if you able to identify the problem statement and the appropriate algorithm, you're good. You can definitely apply for ML stuff. Okay, you are eligible to run ML stuff, right? So let's start with the simplest model, right? Let's start with the simplest model. We'll discuss the logistic regression. Right. So it's a classification problem, right? So suppose we only look at one feature, right? Delivery delay. I'll put some sample data here, right? Customer ID 1, 2, 3, 4, 5. And this column delivery delay. And then this is my target, right? So 0, 1, 2, 3, 4, something. Here there is no churn, right? No churn, but here it is yes, yes. Right? A simple observation. If you do high delay means what? High delay implies high chances of churn, right? So you might think, okay, delay is 2 days, maybe 10% of chance of churn. Delay is 5 days, maybe 50% of chance. So like that. So suppose if you, try to plot this, let me, sorry, just plot like this. Okay, it's a simple S-shaped curve, you will get it. So this is my delivery delay. 0, 1, 2, 3, 4, 5. 0 delivery, I have only 2 values here. This is yes and this is no. 0, no, and 1, here it is no, 2, no, 3, yes, yes. So if I plot like this, it will be a S-shaped curve, right? So at first, probability increases slowly, then rapidly, then stabilizes. Okay, so logistic regression is the same problem actually. So it will ask, what is the probability this customer will churn, right? So what is the probability that this customer will churn? Now suppose you have this curve you plotted from your logistic regression. Tomorrow there is a customer's data updated here. One customer, random customer, customer ABC, right? This X is delivery delay is 3. Now, if business asks, say, what is the probability that this customer will churn? You plot it here. So there is a high chance he may churn, right? So if customer A, the probability, I mean, if another customer, if it is delay is low, the probability is this one. So if you try to build an equation on this one, right? So you use this equation. If whenever new customers data comes in, based on the probability, you put. So randomly, people use threshold as 0.5. If the probability is greater than 0.5, then it is, maybe you can actually think of a simple mathematical equation, right? So wherein if you put a condition, this is greater than 2 and is yes or no. So the probability is greater than 1, then prediction. So logistic regression is also like that. It's a kind of a risk calculator. It calculates, it doesn't say yes or no. It only gives probability, right? Whether 0.05, 0.5, 0.3. And you put a threshold saying that, okay, if it is greater than 0.5, then classify it as yes. If it is less than, then it is no, right? So it's a simple equation. How this works is mathematically, there is this log likelihood estimation. Again, I'll spend few minutes. I don't want to, mess you all with heavy math here, right? If anyone is interested, I will be, uploading a detailed math intuition separate playlist, okay? But here at a, a job ready kind of discussion, these things, you need to understand the basic logic, right? So this is my y is equal to a plus bx. Instead of what I'll do is if I have more and more, I call features, I'll put beta naught plus beta 1 x1 plus beta 2 x2 and so on up to beta n xn. So you simply take odds, y by 1 minus y and do different math here, and then you get probability that likelihood, I mean log or favorable to your whatever y is equal to s equal to your beta naught. There's a e to the power of something. There's a formula. I mean, I'm not sharing all the math here, but some formula. So the algorithm will estimate this beta naught, beta 1, beta 2, and then substitute here, then you will get a probability. Simple. Okay, so that is the method is log likelihood estimation. So wherein it starts with 0, it calculates the odds, and then it will increase both the directions, left hand and right hand, 0.01, 0.02, and so on up to infinity. Similarly, 0 minus 0.01, like that. It will increase different values of beta naught, beta 1, for which set of beta 1, beta, and so on. The odds is good. I mean, the probability, your accuracy, your actual and predicted values are matching or close, then that particular value set is fixed as the estimates. Okay, so that is a simple intuition at a high level. I've given mathematical intuition, right? So that is logistic regression. It uses some log likelihood estimation method, right, wherein it try to predict and calculate the probability. Then you use that probability to make a decision whether the respective customer will churn or not. Then the next one, decision tree. Now imagine how a customer service manager thinks, right? Manager says that question one, hey, the delivery delayed. You say no, the delivery is not delayed. Then customer probably stays, right? The second one. So if delivery is delayed, yes, the customer may leave. Simple, right? This is one question. The second question, hey, is the rating below? Is the rating below 3? Yes. Then there is a chance of customer may churn, right? If rating is greater than 3, then there is a chance that the customer may not iterate. And the customer raised a ticket, yes, then there is a chance of churn, right? If answer is no, then there is a chance of not churn, right? So decision tree is also a similar kind of algorithm wherein it starts with the complete data set, try to come up with the thresholds or the rules from each and every feature that you have given, and it will identify the respective features and build an equation using the entropy and different mathematical values for you to get the probability in similar way how it is calculated in logistic regression. Wherein logistic regression, it's a log likelihood estimation. Here, this is simply kind of counts like, okay, in this set, suppose if I say this is my complete data set. The first question is the delivery delay? Yes. How many customers churned? Is the delivery is not delayed? How many customers did not churn? Yes or no? Yes or no? Like that, it splits based on the entropy and Gini coefficients. There are some mathematical coefficients it will calculate, and it will come up with the best set of the rules to classify the goods and bads, the churn and non-churn customers, right? So decision tree learns a sequence of business decisions where the split is really meaningful based on the probabilistic value, the Gini or entropy, different measures are there. Okay. Similarly, if you have more 20 plus categorical, sorry, 20 plus features, it will split. I would suggest, decision tree or random forest is really good when you have more and more categorical data. Categorical means is delivery delayed, yes or no? Is rating is greater than 3, yes or no? Is service tickets are more than 3, yes or no? These kind of categorical data exist, then good to use decision tree. But implementation, decision tree is not really a good one in the business. Most of the cases we do either logistic regression or random forest or 94% XGBoost. I'll tell you why it is not. Okay, so that's about decision tree. Again, I'm just giving high level math intuition. Okay, so this is not a detailed math. So you should have at least basic understanding. That's the reason I'm giving high level math. Then the random forest. Simple. Random forest is called as an ensemble of all of your decision tree. Okay, Suppose if you have data set, machine will build one decision tree, another decision tree, and so on up to 100 decision trees, then aggregate all these decision trees to conclude the rule for your classification, yes or no, right? So let's say customers from city 1, customers from city 2, customers from city 3, like that, right? So each tree learns slightly different rules. And then finally, which tree should we trust is it's an aggregation. It's actually ensemble. It's called as ensemble. This is also called as voting mechanism. Tree 1, 2, 3 features are high in penetration for a probability, yes or no. So it picks those features based on the voting. It will identify the top 10 or top 5 features. It also helps which feature is actually important, which feature is not important in making a decision of whether the customer may churn or not, right? So simple analogy, if I give a simple example. So imagine asking 100 doctors instead of one doctor. That's it for a diagnosis. Sometimes what we do, we go for a diagnosis. Then what we do, that's the usual thing, right? Everybody will say that indeed today's like take the second opinion, take third opinion, right? So instead of you asking one doctor, you ask 100 doctors. That is actually one decision tree, and so on up to 100 decision trees. Take the voting and get the best output using random forest. Okay, so basically random forest is an ensemble wherever there is a feature was not segregated, there's a chance that it will kind of considered in the next turn. So optimistically you are using the entire data to get the best prediction. So I suggest to prefer random forest when you have more and more categorical features. Otherwise boosting is the best technique. So we discussed about uh, decision tree, random forest, and this boosting is also a tree based, the way how we just discussed, right? So it starts splitting based on the best feature, based on the entropy and Gini values. It will continue. The tree will grow, and you have to set the rules to prune the tree. To prune the tree, where actually you have to stop, so that you're not you're not building a overfitting fitted model or a underfitted model. We discussed about what is overfitting and over underfitting. All right. So this also a tree-based model, right? So what is XGBoost? Extreme gradient boosting. So random forest is called as bagging. So one tree, second tree, and so on to 100 trees, it bags, right? So it bags and it gives the best prediction. Wherein this is boosting, means for suppose there is a one tree, right? If suppose there are some observations which are not classified accurately, then the model will take those observations, try to boost, right? So give some more weights and then include those which were not classified properly and try to see if there is a better classification, right? So that is at a high level XGBoost. Instead of building independent trees, what we do is the XGBoost focus specifically on those misclassified observations, right? So your tree classifies yes or no. Wherever the observations are classified wrongly, right? Based on when you compare with your actual data versus your predicted data, right? Then you try to give more weights to them and then give get the best prediction. So that's why it's very popular. It's very popular these days. I'll give a simple example for you to understand as in a layman example. Imagine a student is preparing for exams, right? So read the entire textbook repeatedly is a bad approach, right? Means you're building the same tree on the same data again and again is bad approach. The smart is focus on the mistakes that he has done in the previous internal assessments, then focus on those things and attempt the examination, right? Simple. Similarly, XGBoost focus on the observations, which observation caused the misclassification, give weights to those observations and try the enhance the accuracy, right? So simple. Many random forest trees, we build many trees and vote independently, take the majority one, give it as a backed output. Where in XGBoost, it learns from the previous tree where misclassified observations, give weights and include them and try calculate the accuracy. And if it is good, then done. Okay, so that is actually XGBoost, right? So now to conclude, when to use which algorithm? Simple. If you have more and more features, I'm telling you with my experience of 15 years in data science, right? So if you have hundreds of features, you're not sure, you don't have time to spend on these hundreds of features after cleaning the data and all, right? Then go with XGBoost and see if it is able to pick the top 10 features with a good accuracy of 80%. It's simple, right? These days in a code, you take a random data and try all the models like XGBoost, Random Forest, and Logistic. These three, definitely this one will give high accuracy. How you improve this accuracy? It's called fine tuning. Hyperparameter fine tuning. So I'll explain when we discuss the Python code of each and every algorithm. So how to fine tune and get the best output, right? So logistic regression gives the probability, right? Wherein XGBoost gives the maximum accuracy because it learns from the previous mistakes and makes sure that it optimizes the classification, good classification, right? So to close, notice something. This is important. All four models are trying to answer exactly same question: which customer is likely to churn. The difference is not the question. The difference is how each model learns the answer. So logistic regression learns probabilities by applying likelihood estimation method. Decision tree learns the rules based on the entropy Gini values. It picks the best rules based on the voting. Random forest, it builds so many decision trees based on the voting from each decision tree. It will come up with the final rule to get the classification, wherein XGBoost learns from the previous mistakes, previous misclassified observations. So, and in the next hands-on exercise, we are going to build all four models on the same Shopspeare data set and see which one performs best. Okay. So, I just briefed, how different algorithms works at a high level. Again, I'm stressing on one important thing. This masterclass is foundation. Okay. So to give a glimpse of how ML, DL, everything, works together for an organization. So the expectation is you to have a clear understanding of data through AI, right? So later, I'm planning to, build in-depth courses wherein you can actually learn everything in one course related to one particular topic. Okay. So here now I have prepared this document. You can find this document in the same folder, right? So churn modeling, step by step, I'll explain, I'll walk you through, then I'll show you the code and the output. I'll discuss the output, how people read it. All right. So the objective is very clear. We discussed a few minutes back also. It's to predict the churn at a customer level. So whether this customer will churn or no, right? So that is the objective of this particular algorithm, this model, churn modeling. So churn means a customer did not place a second order within 60 days after their first order. This is the rule. So this is the business rule given. Again, this is completely fictional thing, just for your understanding. Okay. So this business rule is what business is saying. Okay, if a customer made a purchase on, let's say, April 1st, 2026. Suppose if he is not making another purchase until July 1st, then April, May, sorry, June 1st, 60 days. Not placing, this is the first order. The first order is making on this one. Forget about the second, third customers, I mean, the existing customers, but the first ordered customers. Within 60 days, if they're not making a purchase, then business is saying that that is churn. So you have to prepare the data, check the customer ID and check the transaction date, check today's date. If today's date to the previous transaction date, whoever is doing the first transaction, okay, if it is 60 days rule is breaking, then just give this guy may churn, right? So that is at a high level business objective. Now, data set. So the model uses multiple Shopspeare datasets. I have gone through all these things in detail, like customers, orders, reviews, support tickets, click streams, right? So, sorry, yeah. So this is the set of data sets. So you have to have customer information, order. Why orders is required? To check whether it is a first order or second order within 60 days, right? Customer satisfaction to pick that variable, whether what is the rating, complaint and the number of service tickets, all these things. Right now, the for in Python, I think if you're already aware of Python, then you have to import few libraries like pandas, numpy, matplotlib, XGBoost, all these things, because the functions, respective functions exist in those libraries. So download those things and it's there in the code. I'll walk you through. Then load all the data sets, CSV files, whatever available in that folder. You just download and put it in a folder, give that path. Now, so this is actually called data preparation for modeling. Okay, so what is data preparation for modeling? Date conversion. So date columns are converted from text format into proper date format, right? So why? Why? Because while ingesting the data, date might have stored as a text. So to use that column to calculate, for example, we have to calculate the difference between today and the first order of a customer. If there is no order in between, we have to assign churn, right? So for that, you need to get the format, proper format. So days between first and second order, support tickets raised within 30 days, clickstream activity before first order, tenures when he actually onboarded, right? This is also called as month on books, since how many months he is active with ShopSphere. So to calculate these features, these are called as derived features. These are not directly available in the data set. So you have to derive. It's a derived features. So without date conversion, we cannot calculate these things. So that's the reason we have to do proper date conversions. Then very important thing, define the target variable. So right, so I just explained some time back also, right? So for each customer, first order and second order, the condition is sorry, days to second order equal to second order date minus first order date. If it is greater than 60, then order within days 0. Churn 0 means what? He is active. Churn 1 means he is inactive. Churn means leaving or becoming inactive. He is not making any purchase with your business, with your through your platform, right? So these are the rules that you have to define. So this is there in the Python code, everything, but I'm going to the documentation. So you need to understand the logic first. So step by step, what are the blocks that are there in the Python code? So you need to understand the logic, what is there in that block, each of the blocks, right? So this is the definition of the target feature. Then you have to prepare the customer features, the customer related features. So what do you mean by customer related features? So I need to build the equation, right? My y equal to a plus bx, or my probability of y equal to yes or no equal to 3 to the power of minus something. So this is basically, you need to identify the top feature which are actually driving for a customer to become inactive or churn. So loyalty tier, mobile app usage, preferred channel, all this information is available, the data tables that we have, right? So prepare the data set. Then you have to, calculate some features related to reviews, first order review rating, if there is any negative review rating, right? What is the meaning of this is basically average rating for first order. For example, if there is a customer, right? So customer ID. So if customer ID 1, 2, 3. So his first order, okay, the rating is 3. The second order, the rating, sorry, is 4 or 5 something. So if you want to calculate the average rating, so you can calculate that, and that actually can be fed as a feature into the model, right? So negative review means if there is any review like 1 or 2, it's a negative. Or if the sentiment also, there is a column in our data set, it's a sentiment. The negative sentiment, you can create that flag. So if the first order experience was poor, the customer may more likely to churn. So that is the reason it should have all these informations. Support ticket features you have to calculate. Like these are all the features. Again, I think I mentioned a minute back, derived features, right? So you are calculating new features. That's the reason, data preparation is very, very important, right? So if you have a clear understanding of what these features related to each other, you can easily build. All this comes through experience, the business rules. So, right, sometimes business asks to create these features. Sometimes you have to, being a data scientist, you have to suggest to the business saying that, okay, tickets 30 days. How many tickets he raised in 30 days? Suppose why? Just think the cause and effect. If more and more tickets he is raising, means that may influence the inactiveness, right? So this is important. So think of these sort of variables and you can create any number of variables and pass to the model will pick up the best 10, right? So, and also you have to check logically whether those 10 are making sense to the business or not. I'll discuss about that when we discuss the output. So average resolution time, average time taken to resolve the ticket. Suppose if, let's say last 30 days, the average time taken to resolve tickets is increasing, is higher, suppose. That means there is a chance of this guy may become inactive. Similarly, high urgency tickets. So how many high urgency complaints this guy has raised? This is also, if the lower the number, that means he is active, he will be active. So now the way why I'm explaining all these things is now you relate when we discussed about the theory. Machine is trying to understand, the machine learning algorithm is trying to understand the relationship between your target and your X feature set. So patterns, okay? So the pattern, then it actually builds that equation. So this is very important. If there are more and more high urgency complaints, that means what? Customer is not happy. Or maybe if he is raising more and more urgency complaints, if they're not resolving in with lesser time, then there's a chance that customer may be unhappy and he may leave. Sure. Right? So that's the reason these sort of features are important for this churn prediction. Click stream features. So you can see what is the browsing activity. Clicks 30 days, in last 30 days, how many times he clicked. Average page load time. Is load time. Why this is load time is important? Sometimes we get frustrated, right? If suppose if I enter, suppose if I enter an address website, right? If it is taking so much of time to load the page, then my customer service experience will go down, right? So that's the reason this is also important. So think of these kind of derived features which are relevant to your business question. How many product views happened in last 30 days? How many he had added to cart, right? How many searches he did. So all these numbers will tell you a story. Okay, the behavior of a churn customer is so and so, wherein average page load time is too high. Oh, that means he's not happy with the page load. So there is a chance that he may, right? So that's the reason every feature is important. These derived features especially, which tells the story actually. The pattern tells the story. The behavior. See, digital behavior can indicate customer intent, customer friction, right? The page load time. So frictional issue. So unpurchased journey quality. Then some additional business, what you could say is business features, right? So delivery delay flag, high discount flag, high value order flag. Why this is important? Suppose delivery delay happened, right? So the customer may be unhappy and this may lead to churn, right? Discount was 20% or more. So suppose you are giving more and more discount, there's a chance that this guy will be active, correct? Every purchase, if you are giving discount, obviously customer will be happy and he may not churn, he will be active. Similarly, high order value above median means what? Suppose if there are 100 customers, the 100 customers making a purchase of, let's say, $10, $5, $2, and so on, to take the median value, which is coming around $25, for example, if any customer who is making purchase greater than 25, that means he is a high value order. I mean, the respective order is high value. Why this is important is high value orders and delivery time and something else is together causing churn. It's a multiple interactions, right? So not only one rule that we are actually classifying the churn is or no. You're bringing 100 rules, machine will identify the best to check the patterns of behavior of churn versus active, right? So then the feature selection. So this is the processing. This is the part of model. Like, once you prepare all 100 features, once you have the data, so you just give like, so okay, one more thing here. This numerical features and categorical features. So all features which are actually the numbers, right? Like dollar sale, number of tickets, and dollar discount, right? Or discount percentage, number of times called customer care, something. So any number is a numerical feature. What about categorical feature? So device type, right? And event type, source, right? Page view, whatever it is. So these sort of things are called categorical. So you have to separate those two. So to analyze, if you want to do any EDA, so that machine will understand for processing, pre-processing. I mean, you have to do a different pre-processing. I'll discuss when we go through the code. But yeah, one hot encoding, because machine, I told you during NLP also theory class, machine never understand text. You have to translate it to a machine understandable language. So that is numbers. Categorical features, you have to give some codes. There are two ways to give the codes here. So one is we call as one hot encoding. Okay, so basically 0, 1. It's also called as a dummy, get dummy. It means what? Suppose if there is a column x1, it has values like yes or no. So give s as 1, no as 0. Okay, it's called one hot encoding. Instead, if there is another column called x1, that is actually device type. This device type, let's say web OS, I'm sorry, not device type, source type or something. iOS or Android, for example. Then you can say 1, 2, 3 or 0, 1, 2. Or simply, if this is not an ordinal data, this is not ordinal data, right? So you can do flags like, web flag, yes or no, iOS flag, yes or no, right? Android flag, yes or no. Means the same column, which has three different unique values, it creates three different columns. This X1 is transforming into three columns. Just wherever there is a web, it gives one, otherwise it is 0, like that. Okay, so that is one hot encoding. Okay, so then, so I'll discuss again this part, when we go to the code, that's feature selection, right? So next is train test split. This I have discussed in our previous session theory class. So you have to split the data and build the pre-processing like, standard scalar, one hot encoder. So these just now I explained, right? So this is categorical. Why standard scalar? This is one important point. What is the standard scalar, right? So there is a feature called dollar sale. There is a feature called number of tickets raised. There is a feature called number of items. So dollar sale unit is dollar. Number of items is just a number. So all the numeric features may not be necessarily having same format or same measure, same unit. So to make it consistent, it's good to use standard scalar. This is one reason why we use this scalar transformation. What is standard scalar is basically you have number dollar sale, right? So this function is applied on all the values of this one. So you're shifting origin and scale. It's simple. This is, imagine this is your x, right? So x minus its mean by standard deviation. So every number is transforming into a different number. So the reason is that to make sure all the numbers are having same unique, consistent, I could say, sorry, consistent or unique format or unit. This is one reason. Second is sometimes, if the distribution is a bit weird to a feature, it's also good to use some transformation to bring that to normal. Why? Because if your distribution is weird, machine, it's difficult for machine to get the pattern to build the equation between y and x. Okay, so numerical features and categorical features. So once you have different pre-processing like one-hot encoding and standard scalar, all right, then the model. So we'll be running all four models as I just explained some time back: theory, logistic, decision tree, random forest, and XGBoost. Then I'll walk you through what is hyperparameter and all when we discuss the code. These are kind of, the levers basically, right? So just think of the knobs in the music, orchestra. So to get the best sound for you, you adjust your knobs, right? Similarly, there are different parameters for all the algorithms. So you adjust, slightly adjust based on your output and make sure that you get the best accurate output. So that is actually hyperparameter tuning. I've given few. I'll upload this document. You can go through it. Okay. So then the evaluation metrics. Yesterday, in the previous one also we discussed the accuracy, precision, recall, F1 score, ROC, and all. I'll walk you through. I'll explain how to read each of those measures just by looking at the numbers. Okay. Then the best model we can pick based on the output. The confusion matrix is nothing but you have to do a cross tabulation between your actual values versus your predicted values. That actually helps you to calculate accuracy. Then ROC curve is again another measure, right? So I'll show you once you run the output. The feature importance. This is important. Feature importance is basically to understand which feature, right? Out of 100, suppose you prepared your data set with 100 features, right? So, sorry. So what are the top 10 features which are enough for me to build my model? Y equal to yes or no, the probability that the customer likely churn or not, right? So this is feature importance. So I will discuss, I'll add more, detail when we walk through the code and the output, then you will understand easily, right? So that's it. Then the prediction output and yeah, business usage. So this is I've given the comment of the code also, right? So all these things I've given the step by step. I'll just go to the document once you practice the code and data, right? So then you will get more clarity. Now let's see that we run in Python and I will explain the output. Then you can easily relate to the theory that we just discussed. Okay. So let's go through the code at a high level, right? And also let's discuss the output. So I've briefed you all, how all four models works mathematically at a high level, and we discussed how the data got prepared, everything, right? So now this is the code, okay? So this is also available in the same folder. You can practice this just by replacing the path of the data sets. Okay, you have to give your directory where you have actually saved the data sets, right? So basically, the goal is to predict whether a customer is likely to churn after first order or not, right? So all these four algorithms that we are applying. Okay, so very importantly, if you are not familiar with Python, okay, so once you install an account on Python, make sure you install all these libraries. So pandas, numpy, matplotlib, sklearn, right, and XGBoost, all these things you have to install because the mathematical functions which we are using or calling to run on our data is available in these libraries. For database related, this is pandas. For numerical, vector calculations is numpy, matplotlib is for visualization, right? sklearn is scikit-learn. Basically, it's a machine learning algorithm, mathematical or statistical algorithm stored in this library sklearn, right? So all these things you have to get, and these are the metrics. Basically, I'll explain the output, how to read all these metrics. So this is the standard, importing all the required libraries, and now I am loading my data. Okay, so as we discussed a few minutes back, like we have customer data, orders data, reviews, support ticket, and clickstream data. We are directly using few features. We are deriving few features, right? So to calculate all those things, bring all the tables which are there in your folder, customers, order. Okay, so then if you want, you can see how the data looks like. We already have gone through that, right? So one important thing is convert date column. Here, a date column generally loads as a text by default in Python, right? So we have to convert them into date time format so that we can calculate whatever features related to the date, like for example, delivery delayed days. To calculate that, convert that date into a text, right? So this is a simple, function in pandas dot to date time. It's a function. Wherever you see blue color thing, these are the inbuilt functions. PD means you are referring the library that actually you imported. Pandas you are giving alias as PD. Similarly for NumPy NP like that. Okay. So then once you convert your dates and all, the date got transformed. I mean formatted into date instead of text. All right. Now the first thing is we have to define our target variable. So a few minutes back I've explained how we actually define like a rule is if it's churn if they do not place a second order within 60 days of their first order. Every classification problem you have to check with your business and get the rule and make sure that you apply the same to calculate the target, right? So how actually it's a simple Python program, right? So you don't need to practice or by heart these codes. You can simply use any GPT based code options, right? You just prompt with your column names, automatically it helps. Customer ID, order date. It's a simple logic, right? So you're actually sorting, identifying, but by each customer ID, if the date of first order, if the date of the second order is the gap is more than 60 days, then assign churn, else non-churn. So 1 and 0 you are giving. Okay. So that is how actually you are defining the target variable. I'll show you the output also for each and every function. So this is called a kind of code modularization wherein you write each and every part as a function, then you call all the functions to run algorithm. All right. So this is easy for you. It's a structured coding. Okay. JARGPT or Claude will help you to design in this way. This way you can easily identify if there is a error, where the error is, and you can debug that error. Correct. So this is customer level features. Now the next part is once we have the target defined 1 and 0, we have to merge customer demographic data, behavioral information, and the other information like the channel, etc., to get the customer level features. Okay, we have different features: customer level feature, create review based feature. So what this means is basically, so let's say demographic and behavioral information, right? So let's go to the data tab once. I'll show you customers, right? Here you have customer data here, customer ID is there in one table. Okay, wherein what else we need? We need the order information, right? So the order information is available in orders, order item, or maybe orders. So this customer ID actually ordered on so and so date, and this is the value. So you have to join based on this customer ID of these two tables. You have to join these two tables by the customer ID so that you get information from other table also to be leveraged to define your features. This is what actually is happening here. Merging. Merging means you're joining both the tables. So one table is your customer data. The second is the second one target BF features. I'm sorry, no, customer features. You're actually creating a copy. Customer data you're merging with, which table is this? Customer features. Okay, this is already created here. Okay, I'm sorry. Yeah, target DF you calculated, already calculated. So you are merging with the customers table. Okay, so like age, loyalty tier, preferred channel, etc. So then review based features. So review based features exist in other table, this one reviews. So review ID, customer ID. Now again, you can join based on the customer ID to get the sentiment, what this customer has given. Why reviews is important? We also have to see if reviews is also influencing the churn, right? So this is joining those two, merge the reviews and the customer information. Similarly, customer support ticket features. Suppose if a customer has created any support ticket, so bring the customer ticket features is nothing but tickets. So tickets is the table name here. Support tickets. Okay. So the support tickets you are merging with the customer information. So like that, clickstream. So clickstream also you have one table, clickstream table. So clickstream also you are joining. So you are bringing all the tables together at a customer ID level. And then now here it comes additional features, business features. The way I just some time back I have explained, right, in the document. You can go to the document also. So those derived features, right? Delivery delay flag. Suppose if the first delivery delay is greater than 0, then give 1. Otherwise it is 0. High discount flag. If a customer first order is getting high discount, like more than 20% discount, then give 0 else 0. I'm sorry, give 1 else 0. Similarly, high order value. If the first order is greater than the median of all the values of the orders, then give 1 else 0. So you are creating additional business features. So this part is very important. Even in real time, if you're working for an organization, check with the business and see what best sort of features that you can derive. Now bring everything into one. So you have churn flag and you have all the flags or features that we have created. So the data model is ready. The model, the data set or data frame, DF is data frame for the model is ready. Now you have to define what is your X. My X is all other columns, right? Whatever is there in the data set. My Y is churn flag. That is my Y. So the column name is target. Feature columns are my X. The same you are actually assigning here in Python. Then if there are any categorical features, Python automatically detects if it is a categorical based on the data type. The selected D type is object. Numerical feature, if it is not object, then that is numerical features, right? So now you prepared you merged all the tables to extract all the information, calculated the features, some derived features, then you prepared the data set for your model. Then what is the next step we discussed? You have to split your data set into train and test so that you make machine learn on the train data set and then you test for accuracy whether the model is performing well or not. And then processing pipeline. So here you have to, this I explained some time back, standard scalar to bring all the, see, numeric features are scaled and categorical features like gender, state are converted using one-hot encoding. I just explained some time back what is one-hot encoding, right? So this is called pre-processing pipeline. So you can run this code. So it will translate the machine to the numbers, whatever numbers transformed into standard scalar, wherein the categorical data transformed into numbers, one-hot encoding, right? Then now you have to define hyperparameters search spaces. So basically what is this params is basically there are a few hyperparameters like model C is basically the regularization coefficient. Suppose if you see that there is an overfitting issue. We discussed what is overfitting, right? So this C is model will take each of these combination and run and calculate the accuracy, then pick the best one. That's it. It's simple as that, right? So this class weight balanced means suppose if there is an unbalanced data. What is the unbalanced? This is very, very important in classification. So, okay, just I'll explain. Suppose, let's say in your data set, I have 100 observations in my data set, right? 100 rows. Imagine 95 rows contains my target churn, right? Here in this example, churn 1 and just 5 observations, zeros. That means what? 95% of your data is having ones and 5% of data is having zeros. So sometimes, in fraud detection and all, you see 99% of zeros, 9% of non-fraud and 0.1% are fraud. So this is called imbalanced data or unbalanced data. So you have to make this balanced. So there is a technique called SMOT. So you will learn, maybe I'll take another, deep dive course on this topic. But yeah, so right now we are using a fictional data. Just for your understanding, you can use just classes balanced. Okay, so machine will understand that. Otherwise, you can go for SMOT technique to make this balanced. What it will do is it will actually create a proxy sample to make this sample unbalanced. That's it. So, and as I discussed some time back, hyperparameters. we have only two hyperparameters. One is solver, which method actually it is using. It is a linear or LB FGS. Different methods exist. You can see the documentation in Python. But yeah, C is the replication coefficient. You can pass different values like 0.050, 0.001, whatever you want. See the best value where you are getting high accuracy. So this is about logistic regression. Similarly, decision tree, max depth, min sample split, min sample leaf. These are the key hyperparameters. What is max depth? Max depth is the depth of the tree. For example, see. For example, if you are starting your tree, like this is one, depth one, and this is again you are splitting further, this is depth two, and so on. What is the max depth that you want to do? The second, similarly, the other one is minimum sample split. How many observations if the tree reaches to split further, it reaches 10 or 20, there also you can prune it. That's called tree pruning parameters. Okay, minimum sample split. If you want to split further, the sample should be minimum either 2 or 10 or 30. Machine will run different iterations of each and every combination of these parameters, get the accuracy, pick up the best one where the accuracy is high. As simple as that. Similarly, random forest, how many decision trees you need to build. As sometime back we discussed it, right? So it's a decision tree 1, 2, 3, and so on. So 100, 200. Similarly, max depth, min sample depth. So these are the hyperparameters for decision tree. So XGBoost, again, n estimators is nothing but how many trees. So that is 100, 200, max depth, learning rate. Learning rate is each and every time when it is picking up the unbalanced, misclassified observation, what is the learning rate? It's a coefficient basically. Subsample percentage for the next tree, like that. Okay, whole sample by tree means out of 100 features, how many features, 80% or 100% of features you need to pick for the next iteration. So these are key hyperparameters. If you want to understand these algorithms in depth, so I'll be putting more detailed, topics, I mean, more detailed videos on these algorithms as well with examples. Okay, so you can, get, but for now, my objective is for you all to understand the foundation. Okay, so how a classification algorithm works. So then once we have defined all the parameters of all the models, so my job is to run the model, right? So model, I'm actually storing all the best result into one class here. So grid search is nothing but you are actually giving combination of multiple things. So for example, in decision tree, right? So 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3. So 5 into 3 into 3. So 15 into 3. So approximately 75 times the model will run. Because first it will take max depth as 3, and then 2, and then 1. Then 5 to 1, 8 to 1, 12 to 1, like that, all the combinations. So 78 times or 75 times it will run, and it will pick the best combination. It just runs in minutes. If the data is huge, it will take time, but yeah. So this will run and it will pick the best model and store into the best params here. So here the best model, the results also, right? So that is called grid search. Grid search means it will take the combination of all these things and search for the best accurate model combination, right? It will display all the output. Then you compare all the models and pick the best one. So evaluate the best model in detail. I'll discuss all these things in output, right? So this is basically the to extract final feature names. This is important. In the final model, what are the top features actually occurred? Because model will take a few features. You have actually given some subsample, right? So which set of features actually given high accuracy? That is a top model feature. It will display here. Then the feature importance. Then interpretation, I'll discuss in a while. So let's go to the output. So this one, right? I mean, to be very honest, if you are completely new to Python, just give the structure of your data, like all the column names in GPT prompt, and ask to build the Python code, a structured Python code, a framework like this. It will give the code. Simple. This is not the best way to learn, but as a beginner, you can start in this way. Eventually, you can become an expert in Python. output. So see the customers 10,000, 1,000 customers data, 10,000. This is we discussed, right? The brief about all the tables. Now churn, it is defined. 80% of the flags are the rows are having customers are having flag 0. 19.6% are having 1. That is about the target distribution, right? Then total 1,000 rows and 38 columns because 1,000 customers are there. The data is at a customer level. Out of 38 column, let's see which one has actually appeared in the final model. The training and testing, you're splitting into two parts, right? So 75, 750 and 250, 75% and 25%. You can do 80-20 also. So logistic regression, you see here, so 3/4 of 8 candidates totaling 24 fits. 24 times it ran the model. And decision tree 135 times. Random forest 72 times. Right? So the ROC and ROC area under curve is 0 point. This value I'll explain in some time. Okay. Now let's come to the comparison. So model comparisons, accuracy, precision, and all. Let me take this table and explain you. This is important. This is where right. So this is the output of all the 4 models. So let's understand each of these metrics. So first, let me explain what is accuracy. So accuracy is nothing but out of all customers, how many did the model predict correctly? Means what? So this is your train data, right? So train data, you have customer ID 1, 2, 3, and so on. Then there is a churn flag 1, 2, 3, sorry, yes or no, 1, 0, etc. Now this is your test data. So test data is like 751, 752, and so on up to 1,000. So you have yes or no, yes or no. You made your machine to learn the model, and it is probability of y is equal to yes or no is calculated using beta naught, beta 1, and all. We discussed at a high level, right? So this equation, it is giving probability 0.8, 0. When you score on your test data. So if it is greater than 0.5, you classify 1. It is less than, it classify no. Now this is your actual data. This is your predicted data. So if you compare these two, how many of actuals are exactly predicted by the model? That is your accuracy. Simple. If you have 100 customers and the model predicted 80 correctly, then accuracy is 80%. Okay. That is accuracy. So this is simple, very important, right? Then the second one, precision. So what is precision? When the model says a customer will churn, how often it is correct? Is it correct? Right? For example, model predicts 100 customers will churn, right? But only 30 actually churn. So your precision is 30%. So you're talking only about yes. Wherein here the accuracy, it could be yes or no. Okay. So that is why precision is very, very important. Now the recall. So recall is what? Out of all customers who actually churned, how many did we successfully find? So this is about out of 100, 30 are actuals. Now wherein out of actuals, how many the model able to predict? This is very important for churn prediction because missing a churn customer means losing business. Okay. Then the next one is F1 score. So F1 score is basically, it's a kind of, precision and recall. It's a harmonic mean of precision and recall. All right. So there is a formula to precision plus recall divided by precision into recall 2 into. So harmonic mean of precision recall. Why this is important? This is think of a overall quality score. So this is important. This is you are considering neither precision nor both, either or. So you combine these two and get this score. Again, this is purely based on the actual vice, wherein accuracy is both vice and no, yes, I mean yes or no, both. Now that is your F1 score. So what is ROC basically? ROC tells you how well does the model separate churns from non-churns, non-churners. Okay. So for example, if area under ROC is 50%, it's a kind of random 50-50, right? So if it is 90 above, then it is excellent. So if you notice here, the numbers are very low, precision numbers. Accuracy is okay. Here it is low. Out of all these, XGBoost is bit high actually, right? So XGBoost is bit high, but precision recall are very, very low. The reason is could be fictional data. This is not the real data, it's a fictional data. But in real data, you should have all these greater than 60-70% to conclude your model is best one. Okay. So yeah, just for educational purpose, it's a fictional data. Same, this is also very low. In general, in reality, you won't get these numbers. You should get, if it is a good model, you should get more than 60%. Similarly, ROC also very, very low. Okay, if it is 90% above, then it is good. Okay, so let's see. Logistic regression. This one, first one, logistic regression. So accuracy is 48%, right? Recall is around 34%, and AOC is 41%. So what is this? It is poor performance. Logistic regression performed poorly. An AOC of 0.41 is actually worse than random guessing, right? You can actually put the rules and guess more than 41%, right? It's 50% is a random guess. So that tells us the relationship between our variables and churn is probably not simple, okay, or linear, because logistics also assumes the linear, right? I've explained so this shape, how it arrived and all, right? So very importantly here, it should be more than 60%. Okay, because this model is not able to separate churns and non-churns properly. So logistic regression, you have to ignore. Then let's go to decision tree. 52%, 48%, 53. Okay, decision trees perform slightly better than logistic regression. So recall is 49%. So the model is identifying almost 49% of churn customers. That is good, actually. Okay, that means it is finding more at risk customers than the other models. If you look at this number, this number, this number, all three are low, very, very low. At least this is good. So if you want to consider the business significant reasons or business reasons, this could be a better model decision. Random forest is 76% accuracy is way high, right? But recall is 43, means it is not able to identify the churns. Only 14% churns it is able to identify, right? So at glance, looks at fantastic accuracy, but accuracy is not only the metric you have to look to finalize your model, right? Many of them, many of people who run this, they only focus on accuracy, but this is important, guys. Precision recall, very, very important. Recall is more important, right? So recall dropped dramatically to 14% almost for random forest. So this means the model is missing most. It is missing most churn customers. It is not able to pick up them, predict. Okay, I'll give a real scenario, right? 100 customers will actually churn. Random forest saying that it's only 14%. So do you think it's a good model? No, right? Then let's come to XGBoost. 79%, recall is too low, 2%. AUC is 43%. So definitely not a good model. So highest accuracy, but recall is only 20%. That means out of 100 customers, model is able to identify only 2 churn customers. So 92%, 98% of them you are missing. If you implement this sort of model, your business will see more risky churn customers, right? So again, this is interpretation, how you have to read. Please note, this is fictional data. So just using random functions I have prepared, right? Just to illustrate. So in reality, if you want to conclude a model, it should be, the number should be. Okay. So why accuracy is high and others are low means the reason is simple, right? It's called imbalance. You have seen, right? So the balance, most of them are like non-churn and very fewer churn customers in the data. That's the reason. It's imbalanced, as I said, right? SMOT is a technique if you use. This will solve this imbalance problem. Okay. So high accuracy does not automatically mean a good model, especially for churn prediction, fraud detection, these things, right? So which model would I choose here? If I had to choose from these 4 models today, I would actually choose decision tree. Why? Because recall is high. That's it, simple. And ROS is also a bit high. So decision tree worked out really well because we have more flag features, right? So it is able to split the rules for good and bad, like churn and non-churn customers, right? So you have to interpret the output like this to conclude the best. So if it is a realistic problem, what I do, I'll try to bring more features and do more feature engineering and remove few variables which are not really important, right? It's about interpretation of the output. So precision recall we discussed. Confusion matrix is nothing but basically, so confusion matrix is a cross tabulation between your actual and predicted. Suppose if I say my actual churn yes, churn no, right? So, yeah, this is my predicted volume. So out of 1,000 customers, let's say here I have 250, 150, 400, right? So let's say 350. So it's 500, and then I have 50, just randomly I'm giving. So this is this, and this is my accuracy, the sum of these two. So 350 plus 250. So it's around 600 divided by 1,000. This is 60% is my accuracy. Okay, this is called confusion matrix. It actually distribute the actual Y and predicted Y. Actual Y, but the predicted as no. This is wrong, right? This is actually no, but model predicted as Y. This is also wrong. So I have to reduce these two numbers and I have to increase these two numbers through my model. Right? So that is about confusion matrix. This is ROC curve. Actually, it takes different values of thresholds and put those things. False positive rate and true positive rate. X-axis and Y-axis. Yeah, this is importance. Feature importance means it actually calculates based on the output, right? The beta naught coefficients, right? So once it calculates the accuracy and all, each feature, how much weightage actually this is giving to in prediction. So this is feature importance. So there is no significant to the numbers, but only thing is the higher the best. That's it. So you can pick top 5 and then rerun the model. Just keep only those 5 and rerun the model and see if precision and recall are improving. That is about feature importance. It's just a distribution of how the features actually got this importance. All right. So then you can actually identify once you score risky customers. If tomorrow new data is coming up, you can simply score and tell the business that these are the risky customers. So this is a kind of interpretation guide. Customers with high churn probability should receive retention campaigns to control the churn. Delivery delay feature is important. So logistics can be, improved, maybe driving the churn. So they have to focus on it. Support tickets are more than service, maybe driving the churn. So service should be more efficient. So similarly, mobile app usage, etc., etc. So based on the top features, you can define the interpretation and you can deploy the model once you get the best precision and recall. Okay. So this is a quick walkthrough of ML, how we run. This is again just an example to run the code in Python and all, but in reality, how it works. In reality, a machine learning build, how it works like this. Okay, so I've discussed this some time back, right? MLOps. So you have your data set. You don't import data or bring data to Python and all, right? You just connect your data set to your data warehouse in reality, in the SWS3, etc. So imagine this is your training data set. So this is a pipeline. You build the model, your ML model. Then it actually calculate the accuracy. Once it is done, you deploy it. So after deployment, you have to monitor the result. Tomorrow, when you have new X data, it scores and it will tell you which customer may churn. So once you have the actual data after the respective time, right? Could be day or month. Then you again calculate the metrics. What is the model performance? Suddenly, if you see there is a decrease in model performance, then go back and retrain the model. So this is a life cycle we discussed in ML Ops topic also. Okay. Okay. So that's about machine learning hands-on exercise. I'm sorry. You can actually download this and practice. Look at the output. If you want the same concept churn prediction, you can search churn prediction data sets from Kaggle and apply the same code, practice on your own. Okay, get some understanding. Make sure you understand the concept clearly. Don't use misinterpret the results. Don't use the wrong model, etc. Okay, so that's about machine learning churn prediction. Let's move to the next topic.